Hello, so the topic for my SPL3 is the IPv4, which stands for Internet Protocol version 4. So what is an Internet Protocol, or IP? IP is the principal set or communications protocol of digital message formats and rules for exchanging messages between computers across a single network or a series of interconnected networks. Using an Internet Protocol suite, often referred to as TCP/IP, messages are exchanged as datagrams, also known as data packets or just packets. So the IP is the primary protocol in the internet layer of the Internet Protocol Suite, which is a set of communications protocols consisting of four abstraction layers. The lowest is the link layer, and the highest is the application layer. And in between is the Internet layer and transport layer. The main purpose and task of the IP is the delivery of datagrams from the source host, source computer, to the destination host, receiving computer, based on their addresses. To achieve this, IP includes methods and structures for putting tags, address information, which is part of metadata, within diagrams. The process of putting these tags on datagrams is called encapsulation. So here's like a simple protocol image to like try to lower it down for people that wouldn't really know like how to model or get an image of a protocol. So it deals with agents involved, which is applications, computers, networks, and examples of applications include file transfer and electronic mail, and these execute on computers that support multiple simultaneous applications. So basically this is mostly like connecting different computers and devices with each other. They're like communicating, talking with each other. And so the IPv4 is basically the main protocol that the internet uses today, and is for computers to talk with each other. When two computers talk to each other, data passes from computer to computer, and the IP is in charge of figuring out the path that the data will take, called routing, and it is the backbone of the internet. So what is the main IP used currently, which is the IPv4, which is the fourth reversion of the IP and a widely used protocol in data communication over different kinds of networks. The IPv4 is a connectionless protocol used in packet switched layer networks such as the Ethernet. It provides the logical connection between network devices by providing identification for each device. There are many ways to configure IPv4 with all kinds of devices, including manual and automatic configurations depending on the network type. And at the end of this presentation, I'll show like what it really looks like. It's just like a long, a long row of numbers and letters put together. So the IPv6, which I was talking about earlier, is going to be the newer IP. Is the most recent version of the Internet Protocol, the communications protocol that provides an identification and location system for computers on networks and routes traffic across the Internet. The IPv6 was developed by the Internet Engineering Task Force to deal with the long-anticipated problem of IPv4 exhaustion. The IPv6 is intended to replace the IPv4. So here are the two examples of what the IPv4 address look like and what the IPv6 look like. So basically it's just like a long address for each device, computer, smartphone, for different devices. Every device has its own address system, that is a unique ID for each one of them. So as I said before, the IPv4 is the fourth reversion of the Internet Protocol used to identify devices on the network through an addressing system, just like each house and just like on the GPS, you got different addresses and locations on the map. So it's kind of like that. If you think about it, the Internet Protocol is designed for use in interconnected systems of packet switched computer communication networks. The IPv4 is the most widely deployed Internet protocol used to connect devices to the Internet. It uses a 32-bit address scheme, allowing for a total of 2 to the 32 power addresses, just over 4 billion addresses. And with the growth of the Internet, it is expected that the number of unused IPv4 addresses will eventually run out because every device, including computers, smartphones, and game consoles that connects to the Internet requires an address. So, like I said before, they're implementing on the IPv6 to replace the exhaustion on the IPv4. So this concludes my SPL3 video of the IPv4. Thank you.